Hello students, welcome to NetView Academy. In this video, we're going to learn a very important topic in mathematics called Surds. Surds is a very common topic in the West African Senior School Certificate Examination. Many students lose easy marks because they don't understand the basics. By the end of this video, you should be able to define surds, simplify surds, add, subtract, and multiply surds, rationalize the denominators in surds, and solve WAEC standard questions in surds. Let's begin. Previously, I said that surd is a very common topic in the West African Senior School Certificate Examination. And many students lose easy marks because they don't understand the basics of surds. And so this brings us to the definition of surds. What is a surd? A surd is an irrational root that cannot be expressed as a whole number. For example, the square root of 2, the square root of 3, the square root of 5, the square root of 7. These square roots cannot be expressed as a whole number. Therefore, they are examples of surd. But the square root of 4 can be expressed as 2. The square root of 25 can be expressed as 5. The square root of 16 can be expressed as 4. The square root of 9 can be expressed as 3. Therefore, these numbers that has whole number as their square roots, they are not examples of surd. Surds are irrational roots that cannot be expressed as a whole number. The square root of 2, 3, 5, 7, it is. Simplify the square root of 18. Eighteen is the same thing as 9 times 2. 9 times 2 is 18. Therefore, this becomes the square root of 9 times 2. This can also be expressed as the square root of 9 times the square root of 2. The square root of 9 is 3. Therefore, this becomes 3 multiplied by the square root of 2. Now, since the square root of 2 is a surd and cannot be expressed as a whole number, therefore, the answer becomes 3 root 2. Simplify the square root of 50. Now, we know that 2 times 25 is equal to 50. Therefore, the square root of 50 can be expressed as the square of 25 times 2. This is the same thing as the square root of 25 multiplied by the square root of 2. The square root of 25 is 5. Therefore, 5 times the square root of 2. Since the square root of 2 is a surd and cannot be expressed as a whole number, our final answer becomes 5 root 2. Simplify root 2 plus 3 root 2 plus 5 root 2. Because we have a common root, this becomes 3 plus 5 root 2. And this is the same thing as 8 root 2. Now, it is possible for us to add these two surds because they have a common root. This rule applies to addition and subtraction of surds. If you have something like this, 3 root 2 plus 4 root 3, you cannot add these two surds together because they are unlike surds. They don't have a common root, so you can't add two of them together. 3 root 2 plus 4 root 3 is the same as 3 root 2 plus 4 root 3. Simplify 5 root 2 minus 3 root 2. The rule for addition of surds also applies here. It is possible for us to subtract these surds because they have a common root. And so this is the same thing as 5 minus 3 root 2. Which is the same thing as 2 root 2. In addition and subtraction of surd, the surds must be alike before you can add them or subtract them. But in multiplication, that rule does not apply. In multiplication, you can multiply unlike surds. Question 1 says, multiply the square root of 3 by the square root of 5. So this is the same thing as 3 multiplied by 5, 15. So the answer is root 15. The same thing applies to question number 2. Even though the surds are not the same thing, even though they are not similar, we can still multiply them together. So 2 multiplied by 4 is the same thing as 8. Square root of 3 multiplied by the square root of 5 is the same thing as the square root of 15. If we combine the two values together, this becomes 8 root 15. We have to rationalize 3 all over root 5. This is a very common question in WAEC. Now, to solve this problem, what you need to do is to multiply the numerator and the denominator with the square root of 5. So this becomes 3 all over root 5 multiplied by root 5 over root 5. And this is the same thing as 3 root 5 all over root 25. The square root of 25 is 5. Therefore, this becomes 3 root 5 all over 5. In this question, we have to rationalize this expression. Now, to do that, we need to multiply both the numerator and the denominator by the conjugate of 2 plus the square root of 3. And the conjugate of 2 plus the square root of 3 is equal to 2 minus the square root of 3. So we are going to use 2 minus square root of 3 to multiply the numerator and the denominator. And this becomes 4 multiplied by 4 over 2 plus root 3, 2 minus root 3, all over 2 minus root 3. This is the same thing as 4 multiplied by 2 minus root 3, all over 2 plus root 3 multiplied by 2 minus root 3. So this is the same thing as, if we use 4 to multiply everything inside this bracket, this becomes 8 minus 4 root 3 all over. If we multiply this bracket with this bracket, this becomes 2 multiplied by 2 is 4. 2 multiplied by minus the square root of 3 is minus 2 root 3 Root 3 multiplied by 2 is plus 2 root 3 plus root 3 multiplied by minus root 3 is minus root 9. So this is the same thing as minus 2 root 3 plus 2 root 3 is equal to 0. Therefore, this expression becomes 8 minus 4 root 3 all over 4 minus root 9. This is the same thing as 8 minus 4 root 3 all over 4 minus 3. Square root of 9 is 3. This can be expressed as 8 minus 4 root 3 all over 1. 4 minus 3 is 1, which is the same thing as 8 minus 4 root 3. Root 72 minus root 32 plus root 8. Now, to be able to do this, I need to make this surd to have a common base so that I will be able to subtract and to add the surds. So, the root of 72 is the same thing as the root of 36 multiplied by the root of 2. And the root of 32 is the same thing as the root of 16 multiplied by the root of 2. The root of 8 is the same thing as the root of 4 multiplied by the root of 2. And this is the same thing as 6 root 2. The square root of 36 is 6. Therefore, this is 6 root 2. Square root of 16 is 4. Therefore, this is 4 root 2. The square root of 4 is 2. Therefore, this is 2 root 2. Now, if we put this into the expression above, this becomes 6 root 2 minus 4 root 2 plus 2 root 2. If we apply the rule of BODMAS, it means that we have to do addition before subtraction. Therefore, we have to add this value, minus 4 root 2 plus 2 root 2. This is the same thing as 6 root 2. Minus 4 root 2 plus 2 root 2 is the same thing as minus 2 root 2. 6 root 2 minus 2 root 2 is the same thing as 4 root 2. Now look at the expression on the board. In this example, we're asked to simplify the square root of 72 minus the square root of 32 plus the square root of 8. These numbers cannot be expressed as a whole number. 72 cannot be expressed as a number, 32 cannot be expressed as a whole number, root 8 cannot be expressed as a whole number. But we're able to simplify the expression because we break them down into perfect squares. So we have root 36, which is 6, root 16, which is 4, and root 4, which is 2. So whenever you find yourself in this situation, whenever you have this type of scenario, always break down numbers to perfect squares. When you're solving problems that have to do with addition and subtraction, always make sure that the surds are alike. When you are rationalizing, always make sure that you find a conjugate of the surds that you are rationalizing. If you like this video, don't forget to share the video. Don't forget to follow us on Facebook so that you can have access to more of this video. For more of content like this, follow me on Facebook, like my videos, share my videos, and post your comment in the comment section. I'll see you in the next video.